Hello, my name is Fiona Horvat, and I am a senior at Montclair State University studying exercise science. In November of 2020, I attended the Mid-Atlantic Regional Conference for the American College of Sports Medicine and had the privilege of presenting this study during their undergraduate award session. And this study is titled Variable Height Step Test Provides Reliable Heart Rate Response, Virtual Cardiorespiratory Testing During COVID-19 Pandemic. Heart rate responses to aerobic step tests are widely used to estimate cardiorespiratory fitness. The step tests that are available to us today require a prescribed step height. As you can see on the bottom right-hand side, this is what a standardized step looks like in a laboratory or fitness setting. But amid the coronavirus pandemic, many laboratories and fitness centers are closed, which makes it quite impossible for fitness professionals to obtain and provide their clients with the standard step, which brings us to the purpose of this study. And that was to examine a modification on a standard step test, allowing for the use of pre-existing in-home steps of variable height for cardiorespiratory fitness testing. For this study, we modeled the YMCA step test, which has a criteria of a 12-inch step and a step frequency of 24 steps per minute. Using the ACSM step-in equation, which we can see in red here, we plugged in those two criteria and got a VO2 of 25.8 milliliters per kilogram per minute, which is the VO2 that each participant will be working with throughout their time during the study. So for each visit, we met on a virtual conferencing software to assure that we followed CDC guidelines of social distancing. For the screening visit, we went over forms. So we went over contact information, medical history, GPAC, and PAR-Q. We then had them measure a small and large object for which they would be using the stepping on. On the right-hand side in the bottom corner, you can see two examples of what an acceptable step is. Pretty much participants can use any step as long as it's safe to step on and there's no cushioned surface to the top of the step. After we measured the small and large object, we determined the step rate by using that ACSM step-in equation that we saw on the previous slide. For example, if we had a small step of 7.5 inches, we would use the frequency equation, plug in the 25.8 VO2, which we found in the previous slide. Then we could convert 7.5 inches into meters, and we got a frequency of 34 steps per minute for a small step of 7.5 inches. If we had a large step of 17 inches, we would plug in that 25.8 once again, convert the 17 inches into meters, and get a frequency of 18 steps per minute. We then met 3 separate times for exercise visits. The first one was a familiarization visit, which was the small step, and then 2 randomized visits using that same small step and then a large step. So before the test, I had them sit for 5 minutes to assure baseline. I then had them take their 1-minute radial pulse. After that was recorded, I had them step to their metronome for 3 minutes. And directly after that 3-minute step test, I had them sit down and take their 1-minute radial pulse once again. I then asked them what their RPE was on a scale of 0 to 10. For descriptive statistics, we looked at mean plus or minus the standard deviation of the mean. For correlation statistics, we looked at P and R values and the best fit line, but most importantly, for the best fit line, we looked at the slope and the y-intercept. Slope should be anywhere by 1 and y-intercept should be anywhere by 0. This was to assure that there was no bias towards those correlations. So we had 15 participants, 6 of which were male and 9 women. The age was an average of 26 years with an average height of 161 centimeters and an average weight of 74 kilograms, giving us an average BMI of 25. We then looked at test characteristics between the small step test and the large step test. The only two that had p-values less than 0.001 were the step height and the step frequency, which is due to methodological reasoning. So here we have a graph. On the x-axis, we're looking at the small step test 1 heart rate in beats per minute. And on the y-axis, we're looking at the small step test 2 heart rate in beats per minute. We had a p-value of less than 0.001 and an r-value around 0.9. We had a slope around 1 and a y-intercept around 0.5. Again, slope should be anywhere by 1 and a y-intercept should be anywhere by 0. So this graph is showing us that there's a very strong interday heart rate repeatability. On the x-axis here, we're looking at the large step test heart rate in beats per minute. And on the y-axis, we're looking at the small step test 2 heart rates in beats per minute. This gave us a p-value of less than 0.001 once again, an r-value of around 0.9, a slope around 1, and a y-intercept around 1.1, showing us that there's a very strong heart rate correlation between the two different heights. On this graph, on the x-axis, we're looking at the small step test 1 RPE on a scale of 0 to 10. And on the x-axis, we're looking at the on the y-axis, we're looking at the small step test 2 RPE on a scale of 0 to 10. This gave us a p-value of less than 0.001 and an r-value around 0.8, with a slope of around 0.8 and a y-intercept of around 1, showing us that there's a strong interday RPE repeatability. Here on the x-axis, we're looking at the large step test RPE on a scale of 0 to 10, and the y-intercept is looking at the small step test 2 RPE on a scale of 0 to 10. This gave us a p-value of less than 0.001 and an r-value around 0.7, with a slope around 0.7 and a y-intercept around 2, showing us that there's a strong RPE correlation between the two different heights. So in conclusion, modifying step frequency to account for the varying heights of in-home steps will permit the use of previously developed step tests without the need for standardized steps. This study provides the first evidence that fitness professionals can use virtual steps tests without specialized equipment to test cardiorespiratory fitness of their clients when close proximity is not possible. I would like to thank Dr. Matthews, my primary mentor, our co-author, Dr. Phillips, our graduate assistant, Daniel Guan, Montclair State University in the Department of Exercise Science and Physical Education, our study participants, and of course, Mark ACSM for allowing me to present this back in November. Thank you.